All right, so let's see if we can straighten out a new form for D area. One through a cylinder. So we draw a cylinder first, yes? All right, so here's your cylinder. I'm going to assume this thing's centered around the z-axis just for simplicity. This D area form that I'm writing is going to work for cylinders centered around one of the axes. It's not going to work for cylinders that are centered off the axes. Okay. There's a better way to do that. All right, so this cylinder is going to be assumed to have some radius r, right? So if you wanted to tell me about a point on this thing, what would you need to give me in terms of information?
Like a vector?
Let's see, so what do I want here? Suppose what I want is to figure out the area in terms of something, right? So which are the two free variables in this system? To describe a point on a cylinder, right?
Radius and a height.
Yeah, so here's a cylinder. The radius is determined, right?
Oh, okay.
So to tell me about like where this C here is, what do you need?
Height.
You need a height and some kind of angle, right? So what's the traditional letter for height? Z probably?
So we're looking through just the surface.
H maybe, whatever.
H, Z, yeah.
Yeah, so we're just looking at this surface, right?
Okay.
And
That's
then
why I was
there's-
confused. You were using a cylinder and saying area.
Yeah, so I'm saying the area on the cylinder. Does that make sense?
Surface area?
I'm kind of looking at one of these weird little patches. You guys see that? And I'm trying to figure out, on this weird little patch, what's n change in area? You guys see that? So does the z value of this thing matter at all?
No, it's just a.
No, right? A patch is going to be a patch regardless of where it is on this cylinder. You guys see that? So what are the important things on here?
The angle.
The angle's going to matter, right? That's going to cause this thing to be different, right? Do you guys want to give me a guess for that thing? How long is that bottom side of that little patch going to be? Change in theta seems like a good start.
R.
And then it needs an R, right? Because it matters how far out it is.
Delta Z.
And then there's a delta Z for the height. You guys see that? So on this, I know I can replace the delta area, right, with an N times R times delta theta delta Z. Okay, now how about the normal vector there? If this is a point, let me see. What's a point on this thing going to look like?
R cosine theta, R sin theta.
R cosine theta, R sine theta, comma,
Z.
Z, right? Okay, so what's the vector that's perpendicular to the surface there look like?
R cosine theta, R sin theta, theta 1.
So close.
Sticks out.
Yeah, it should look like this, right? It should stick straight out of this thing.
No Z.
And so what I've got here, right, is I've got this vector that points straight out. That's my R cosine theta, R sine theta.
Is it R plus 1? Or is it equal more than 1? I don't know.
So don't bother moving it, right? You don't have to get it there. Just think, what's that vector? Well, that vector is probably parallel to this vector, right? You guys see that? But the vector that sticks straight out of a cylinder is the one that points from the middle out to the edge. So that normal vector there is r cosine theta, comma r sine theta, comma 0. Right, because it's going to be flat. Because if it's got some kick to it, either up or down, right, then it's not sticking straight out of the cylinder. And then there's going to be a r delta theta delta z. And I need to make that n what?
A unit vector.
Yeah, I've got to make it unit length. How long is this vector right now?
Yeah, R.
Is r long, right? So how long does it need to be? It should be 1 long, right? So I should divide it by r. So grand total here, I'll get, what's my new formula? The area of the vector hat is
Cosine theta, sine theta. Would we include the 0?
yeah, I think we probably should. Oh, I don't. What is it?
Just cancel it out.
When they work them out, when they dot product, it's kind of like it's there.
I didn't write one in my notes, but I think I should have.
Makes
Because I should be taking a vector field and dotting it. I think I need that 0.
like in the, I mean, like in the answers, these, when they dot. You know, like in 2, 3.
Yeah, I should never dot 2 vectors with 3 vectors because I don't know whether they apply to the first 2 coordinates, second 2 coordinates, or first and third or something. Dot product should go from same dimension to a scalar. So I think I need this 0 here, just so I know what to do with the z coordinate of the vector field that I'm talking about. But it should be clear, right, that if I'm talking about flux through a cylinder, that the z component to the vector field doesn't add anything, right, because it's flowing parallel to the surface. You guys see that? So I'm going to put this 0 in here. I'm not sure if your book does or not. And then I need d, whoops, I forgot a piece.
R.
Good, there's an r left, right? And then there's a d theta dz. Cool. And this works for things that are cylinders, right? So this works when you're looking at a surface that's given by x squared plus y squared is r squared.
So if it was a cylinder like laying down along the x-axis, would you switch the dz to dx? And would we redefine theta as that? Just leave it cosine sine?
Yeah, so one thing you could do is you could just kind of cock your head at the picture and relabel the variables. As long as you keep the right-hand rule intact, it'll be fine. If you forget and screw up the right-hand rule, it'll just be a minus sign off. Probably. Don't quote me on that. Don't quote me on that. Cool.